Hello everybody. These are the video notes on how to make an atom. Now obviously atoms are already actually made, so this video is really just a video in order to start understanding from symbols and the names of atoms or isotopes or ions, whatever we're talking about. It's how we figure out how many protons, neutrons, electrons there are. So the first thing students must understand is this chart. For 8th graders, for college prep students, this is obviously on page 123 of your textbook. For pre-AP students, we will be taking these notes, if we already haven't, in your notebook. But this table is the absolute foundation for understanding everything we are about to do in chemistry. So the three parts of an atom are proton, neutron, electron. Protons are in the nucleus, neutrons are in the nucleus, electrons are not in the nucleus, they are in the electron cloud. Protons are positive, neutrons are neutral and in the nucleus, and electrons have a charge of -1. And instead of this sentence, I actually want you to know the number. Protons have a mass of 1 AMU, atomic mass unit. So do neutrons, even though they're slightly larger. We're just going to say they're the same. Protons and neutrons have a mass of 1 atomic mass unit, but electrons are so tiny, they are 1/1800th of 1 AMU. So 1 over 1800 AMUs. So that's where we stopped, and now we are about to move on. From that information, now we can look at this handout, which you will receive or have received. It's obviously called How to Make an Atom. What we will start doing is we are going to start looking at symbols like this. Clearly we have zinc here, and in the upper left-hand corner we have a number. In the upper right-hand corner, let's start again. In the upper left-hand corner we have a number. In this case 65. In this corner we have another number. The lower left corner we have a number. And in the upper right corner we have another number. Nothing is in the lower right, because eventually that's where we'll put numbers to say numbers of atoms. For example, H2O means 2 hydrogens and 1 oxygen. So what we are going to do here is, let's go through each one of these numbers. The absolute most important number here is this. The number in the lower right corner is called the atomic number. This is the number of protons. We quickly will stop giving you this number because that number can always be found on a periodic table. One of my favorite websites is this website, ptable.com. ptable.com is a periodic table, and it's interactive. You can click on every element. You can highlight parts of the periodic table. We will use ptable a lot, ptable.com often. So we just looked at zinc. We said the atomic number, the number of protons, was 30. Well, if we now look, we see that the number is 30. I don't have to tell you this anymore. On this first worksheet, this number is always given to you, but the atomic number is a number you always can now get off the periodic table, and atomic number tells you the number of protons. So that is the atomic number. The next number is the mass number. So 65 is the mass number. It tells us protons and neutrons. But if we know that this is protons, because eventually what we're going to start doing is we're going to use these to figure out protons, neutrons, and electrons. We're going to use these to figure out protons, neutrons, and electrons. So we now know that this has 30 protons, because that is 30. Well, now if you go down to this box here, in order to find neutrons, we take the mass number and we subtract the atomic number. So 65 minus 30 is 35. And mass number is the thing that has most of the mass. Those are protons and neutrons. Those are the nucleus. Most of the mass of an atom is in the nucleus. Well, protons tell us what the element is. So 30 protons, 65 protons and neutrons, minus 30 of them being protons, gives us 35 neutrons. Now we look at the charge. This number is the charge. This number helps you determine electrons by following these rules. But this entire huge box, let's reword it just simply. All you have to do is what I call, do the opposite. If you have a positive charge, subtract. If you have a negative charge, add. But only the number. If they're the same, if you don't have a charge, then electrons equal protons. If you have a positive charge, then you have more protons than you have electrons. If you have a negative charge, you have more electrons than you have protons. So in this case, we take 30, but instead of adding 2, we do the opposite. We subtract 2. So 30 minus 2 is 28. And does that make sense that we have 28 electrons? Well, we have 2 more protons than we do electrons, and for that reason, we have a positive 2 charge. So that is how we are going to figure out protons, neutrons, electrons. Atomic number is 30, mass number is 65, our charge is plus 2. Always put a plus or a minus in front of your charge if you have it, and if I ask you what the charge is and you don't have one, please say the charge is 0. Don't leave it blank. So pause the video for just a few seconds and try this problem. Scroll back up if you have to, review the video, back it up if you have to, go back, look at your handout, and try this problem very quickly. I will pause for about 3 seconds, pause the video to do this problem. Alright, we're back, and now we're going to try this problem. First, before we actually do it, let's go back and look at ptable.com. This is bromine, so if we look at bromine, bromine's right there, and there is the atomic number. The atomic number is always in this corner, and bromine is 35, because eventually I won't tell you that number, but for now I am. So the atomic number is 35. 35. The mass number is this number. It's 80. And the charge is -1. Please put the negative. So now let's use some different colors. What is the number of protons? Well, the protons are 35. In yellow, let's figure out neutrons. Well, neutrons are protons and neutrons mass number minus the protons. So 80 minus 35, neutrons is 45. And electrons are, do the opposite, 35. Always go back to the 35, but do the opposite, plus 1 36. And does that make sense? Yes. We have one more electron than we do protons. Electrons have a negative charge, and therefore we have a negative charge, an overall negative charge. So notice, please, 35 is our most important number, because here it's 35. This is 35, or 80 minus 35, and this is 35 plus 1. We always come back to that number because the atomic number is the most important number. So now you are going to do this worksheet. It is two-sided. We will do the first side one day and do the second side the second day, and grade 10 of them on the back for a grade. So I don't want to give away any answers. The one thing I absolutely beg of you, do not do this just to get the worksheet done and do all the atomic numbers, all the mass numbers, all the charges, all the protons. You will never ever get a list, except for this worksheet, where you do all of these in this fashion. Normally what you're going to do is you're going to get a problem like this, and then we fill it in this way. So as you do this worksheet, go across and do each row, because very soon, in the next day or two, I will stop even giving you these symbols. I will start giving you names involving all these numbers except the atomic number, and from the name you give me the symbol, then you figure out protons, neutrons, and electrons. I hope this video helps, and we will continue on in our study of chemistry. Thank you.